Hi everyone, welcome to third help session of the course uh, E220 Circuit Fast. Today we are going to solve some problems. This is the first problem. We've been asked to compute the power supplied by each voltage source in the circuit shown below. In this circuit, there are two voltage source, 3 volt voltage source and 2 volt voltage source. In order to compute the power supplied by each of the voltage source, we need to know V and I, right? Power is given by product of current and voltage. So we need current of each voltage source in addition to voltages. We know the voltages 3 volt and 2 volt, but we also need currents. So assuming currents I1 and I2 coming out of the positive terminal of the voltage source as shown in the figure, the polarity of voltage source we're assuming like this, polarity of, direction of currents coming out of each voltage source, we're assuming in this direction. So if we compute the current coming out of the positive terminal of each of the voltage source, then we can easily determine the power. So in order to compute the current, these currents I1 and I2, first of all, let's apply KCL at node A. What does KCL say? KCL is a current law. So it says that sum of incoming current equals to sum of outgoing currents, right? So for this node 1, 3 milliampere is incoming current, this one I1 is outgoing current, this 5 milliampere is outgoing current. So 3 equals to 5 plus I1. So if we simplify this, we'll get I1 equals to minus 2 milliampere. Now again, let's apply KCL even at node B. In case of node B, 2 milliampere is incoming current, I2 is incoming current, and 3 milliampere is outgoing current. So 2 plus I2 equals to 3. So we get I2 equals to 1 milliampere. Now, since we got I1 and I2, we can easily determine the power supplied by each voltage source. Power supply voltage source 1 is given by P1 equals to I1 into 3 equals to minus 6 milliwatt. It means since the value is negative, that means voltage source 1 is receiving 6 milliwatt power, or we can even say it's supplying minus 6 milliwatt power. So for voltage source 2, P2 equals to I2 into 2, which gives 2 milliwatt. So voltage, this second voltage source, 2 volt voltage source, is supplying 2 milliwatts power. Now let's move to our second problem. In this problem, we've been asked to determine the power received by each of the resistor in the circuit. Here we have 4 resistors, one 6 ohm resistor, 8 ohm resistor, 5 ohm resistor, and 20 ohm resistor. In order to compute the power received by each of the resistor, we know the formula P equals to IV, and it can also be written as I square R or V square R. So in case of a resistor, since we are already given resistance, value of resistance, so if we know either current or voltage, current through the resistor or voltage across the resistor, then we can easily compute its power. In this case, so for 6 ohm resistor, first of all, we need to compute, let's try to compute I2 using KCL at node 1. So when we apply KCL at node 1, this 0.3 ampere is incoming current, I2 is incoming current, and 0.2. All these three are incoming current, right? So sum of incoming currents equals to outgoing current. There is no outgoing current, so it's equal to 0. After simplification, we get I2 equals to minus 0.5 ampere. So now power received by 6 ohm resistor is given by I square R, that's 0.5 square, R equals to 1.5 watt. So in this way, we have computed the power received by 6 ohm resistor. Now, let's compute the power received by 8 ohm resistor. In order to compute the power received by 8 ohm resistor, we need either V5 or I5, right? So it's easy to compute I5. So in order to calculate I5, we need to apply KCL at, let's apply KCL at node 2. So if you want to apply KCL at node 2, 0.5 ampere is incoming current, I5 is outgoing current, I2 is also outgoing current, right? So 0.5 equals to I2 plus I5. We already know the value of I2 equals to minus 0.5 ampere. So if we plug in values of I2 here, value of I2 here, we can easily compute I5. So this gives I5 equals to 1 ampere. So power received by this 8 ohm resistor equals to I square R. I5 here is its value is 1 ampere. So in this way we can get 8 watt. Now in order to compute power received by this 5 ohm resistor, we need I9, right? I9. So in order to compute I9, we need to apply KCL at node 5. In case of node 5, I8 is incoming current, I5 is incoming current, I9 is outgoing current. So we get this sum of incoming currents equals to sum of outgoing currents. In this case, we know I8 equals to minus 3 ampere. These two elements are in series, right? So 0.3 is flowing in this direction, I8 is flowing in this direction. So they are flowing opposite directions. So we can write I8 equals to minus 3 ampere. So when we write I8 equals to minus 3 ampere, and we also know the value of I5, that is 1 ampere, we can easily get I9 equals to 0.7 ampere. So in this way, we have computed the power received by 5 ohm resistor, which is equal to 2.45 watt. So now, in order to compute the power received by 20 ohm resistor, instead of computing current, it's easy to use voltage. These two elements are in parallel. So since this 20 ohm resistor is connected in parallel to this voltage source 15 volt, so we can easily write V7 equals to 15 volt, right? So if we write V7 equals to 15 volt, we can apply this formula V square by R. So when V7 equals to, if we replace V7 by 15 volts, we can easily get this power. So in this way, we can determine the power received by each resistors in the circuit. Now for the third problem, we've been asked to determine the value of current IM in the circuit. In order to determine the value of IM in the circuit, we also need this unknown value of this unknown parameter VA. So what is VA here? VA is the voltage of this element, current source. And we can see this is also a current source, but this is a voltage dependent current source because it depends on voltage at some other point in the circuit. So it is a voltage dependent current source. So first of all, let's try to calculate VA. In order to calculate VA, we need to apply KVL in this outer loop, right? We need to apply KVL in this outer loop. So in order to apply KVL in this outer loop, we need to know the value of this VO1 and VO2. So in order to compute value of VO1, we need to know the current through this element, right? And since this 6 ohm resistor, this 3 ampere current source and 4 ohm resistor, these are in series. So the same current 3 ampere flows through the circuit and in this direction, right? This current flows in this direction. So in case of this 6 ohm resistor, current is flowing from positive to negative terminal, right? Since 3 ampere current is flowing from positive to negative terminal, in case of the 6 ohm resistor, we can easily write V equals to IR equals to I is current is 3 ampere, R is 18 volts. Even in case of this 4 ohm resistor, current is flowing from positive to negative terminal, right? This current flows in this direction. So we can easily write IR 3 into 4 equals 12 volt. Now let's apply KVL in the outer loop. If we want to apply KVL in the outer loop, let's move in any one direction. Let's say we are moving in clockwise direction, right? If we are moving in a clockwise direction, then let's take the polarity while leaving this element. When we are leaving 4 ohm resistor, we'll see plus polarity. While leaving this current source, we see plus polarity. While leaving this 6 ohm, we'll see plus polarity, right? For each of these elements, we are seeing plus polarity while leaving this element. So all these voltages are added. V02, VA, and V01. All these are added to 0. So since we have already obtained V01 and V02, if we plug in these values, V0 and V02, we get VA equals to minus 30 volts. Now, let's apply KCL at node X. When we apply KCL at node X, we can see that this is incoming current. 2 by 5 times VA, this incoming current, 3 ampere is also incoming current, IM is also incoming current, right? So sum of incoming currents equals to outgoing current. Outgoing current is 0. So if we sum this up, we will get 0. Now let's put the value of, substitute the value of VA minus 30 volt. If we do so, we get current IM equals to 9 ampere. So in this way, we can determine the value of current IM. So thank you, everyone. Let's meet in next help session. Thank you again.